Okay, gang, let's look at the sum and difference rules. So if you're taking the derivative of sum and difference, it's the derivative of each piece. So if I'm adding two things, I take the derivative of the first thing plus the derivative of the second thing. If I'm subtracting two functions, it's the derivative of the first one minus the derivative of the second one, okay? So it's just sort of like you just go across taking the derivative. So if you have a series of items, you just take the derivative of each. Alright, so here I'll take the derivative of x cubed. So that's going to be 3x squared. I'm going to take the derivative of negative 5x. And you know what? Let me go out of my way to say something that I didn't say earlier that's important. If you think of the, this is in relation to the power rule. If you think of the identity function, which goes like this, the slope of this function is a 1, which means that if y equals x, the derivative of this function is 1, right? Because that's the slope of this function. So if you have a function y equals, so for instance, 5x, then the slope would be 5, meaning the derivative would be 5. You can use the power rule on this stuff. It gets a little weird if it's linear, but you can do it, right? Because if x is a 1, you bring the 1 down in front, it makes... You bring the 1 down in front, 1 times 5 is 5. You subtract 1, that makes x to the 0. Anything to the 0 is 1, so it's 5 times 1, which is 5. So if it's linear, we don't tend to use the power rule, but it does work if you want to use it. And I wish I had said that earlier, so let me just see if I can fiddle back here for a second. So just because your brain tends to compartmentalize things. So when I was going over the power rule, this case is sort of a special case. If you have a linear, so the slope is 1, right? So you want to sort of, for the linear cases, it might be easier for you just to recognize what the slope is. All right, so back to this one. So see, this one in the middle is a linear case, and it's not like you can't use the power rule on this. It's just that it might be easiest for you to just recognize that if you had the line y equals negative 5x, the slope is negative 5. That just might be the easiest way to think about that. And I'm just going to sort of be a little obnoxious and write this out because I want your brain to start to register this. So now you're taking a derivative of a constant. This was the first rule I taught you. So what's the derivative of this guy? Right? This is a horizontal line if you drew this piece. Right? So that's 0. I'm just being obnoxious because I want you to remember that the derivative of a constant is 0. So now let me just write the answer a little nicer. So it would be 3x squared minus 5 would be the final answer for this. Let me get this a little closer. There we go. All right, let's do that same idea again. Now, if you need me to rewrite this, I'm not sure you do, so I'll just play it safe and rewrite this. So this is a negative 1/2 times an x to the 4th. So remember, you bring the 4 down in front. 4 times negative 1/2 is negative 2. 4 times negative 1/2 is negative 2, right? So you have 4 over 1 times negative 1/2. I tend to reduce first. Oh, you guys don't usually reduce first. Okay, so negative 4 over 2, then that reduces to negative 2. All right, so that's where the negative 2 comes from. And then now I'm going to subtract 1 from the 4, which is a 3. So that's the first one finished. Now I'm going to go on to the next one. So I'll bring the 3 times the 4, which is 12. I'm going to subtract 1 from the 3. That's going to make a 2. And this last case is linear. The negative 2x, right? Y equals negative 2x. If that was linear, you'd say, oh, the slope is negative 2. So the same idea. It means the derivative is negative 2. Just a little easier to do it that way versus the whole power rule. But again, the power rule works. All right, so if you're adding and subtracting terms, you just add and subtract the derivatives of the terms, and that gives you the overall derivative of that function. All right, I want you to memorize this. This one is sort of funky. This says that the derivative of e to the x, you guys remember what e to the x looks like? That's this guy. That's an exponential growth. Has a horizontal asymptote at 0. Right, e, if you recall, is about 2.718, around there. Sometimes we say 2.72. Right? The derivative of this function is itself. The derivative of this function is itself. I know that's weird, but that is what it is. So I want you to memorize that, okay? All right, here we go. Let's do a little bit more of what we just did before, but let's mix the e in now. All right, let's try the first one. If you want to stop the video and try to do these two and then check, that'd be cool. All right, so the first one, bring the 2 down in front. 2x, we subtract 1 from the 2, that leaves us with a 1. We don't tend to write 1 because that looks like a prime. All right, so that's just 2x. Derivative of a constant is what? 0, right? I'm just going to be obnoxious and write 0. I'll take it away in the next step. And then this one I just went over. Derivative of this guy is itself. Really weird, but that's what it is. Okay, so final answer is 2x plus e to the x. All right, let's try another one. Let's do number 2. So y prime equals to, there's your e to the x again. Derivative of e to the x is e to the x. Derivative of x, now that's linear. So if I say y equals to x, what's the slope on that? The slope would be, good, it'd be a 1, right? So that means that the derivative of that piece is a 1. Again, you can do the power rule on it, it'll work. So y prime is e to the x plus 1. All right, let me end this video here, and we've got more rules to go. So I will catch you again in another video. Bye-bye.